Section 3.4 study guide, second problem. So again, we're just going to differentiate this, and we're going to have to use a product rule in this case. So let's first start off by rewriting things just to make things a little bit easier for us. So I'm going to write this whole thing here as x cubed over 3. And instead of square root of this, I'm going to call that 25 minus 9x squared to the 1/2. Okay, so now we're going to start. So notice this is a product of two distinct expressions, I guess you want to call them, or even functions. This is our u. We can call this our v. And remember, when y equals u times v, y prime equals u times v prime plus u prime times v. So let's get started. So y prime is u, left alone at first, times v prime, which we're going to have to use the chain rule here. So we're going to have to find the derivative of 25 minus 9x squared to the 1/2. So let's start by bringing the 1/2 to the front. Times 25 minus 9x squared to the 1/2 minus 1, that's negative 1/2, times the derivative of the inside. Well, the derivative of 25 is 0, and the derivative of minus 9x squared is negative 18x, plus the derivative of the first thing, x cubed over 3. So that's going to be 3x squared over 3, and the 3 that's going to go here as a coefficient when I bring the exponent forward, and this 3 will cancel out, leaving me with x squared. So the derivative of x cubed over 3 is just x squared, times the second factor, left unaltered. Now let's simplify as much as we can. So down here we have 3 times 2. Up here we have negative 18. So negative 18 divided by 3 times 2, or divided by 6 in other words, negative 18 divided by 6 is going to be negative 3 times x cubed times x is x to the 4th. And then we just bring everything else down. We can't really combine anything over here. So this is where I'm going to start to use, or I'm going to use my special technique for simplifying expressions such as this one that contains exponents with the same base, 25 minus 9x squared over here, 25 minus 9x squared over here, but where one has a negative exponent and the other one has a positive. So there's a way to drastically simplify these kinds of expressions. And we're going to have to multiply everything by essentially an expression that equals 1. It's an expression over itself that will cancel things out and just make everything nice and simple for us. So I'm just going to bring all of this down and put it in a giant set of parentheses. So here's what we're going to multiply. We're essentially just going to take the same base that we see here and here, but except we're going to raise it to the positive power, or the opposite of whatever the negative exponent is. The negative exponent here is negative 1/2. So we're going to multiply everything by 25 minus 9x squared to the positive 1/2 over itself. Okay, so we're going to multiply this numerator times each term. And then we're going to multiply this denominator essentially into this denominator. So it's just going to go right under everything. So let's get started. We're going to distribute. So what happens when I multiply 25 minus 9x squared to the 1/2 times 25 minus 9x squared to the minus 1/2? Well, we add the exponents. Negative 1/2 plus 1/2 is 0. So I get negative 3x to the 4th times this whole thing to the 0, because remember we add the exponents when we multiply powers. So anything to the 0 power is just 1 plus x squared times, well, what happens when I multiply 25 minus 9x squared to the 1/2 times 25 minus 9x squared to the 1/2? Well, again, we add exponents. 1/2 plus 1/2 is 1. So that's what we end up with. And then, of course, we have to multiply this denominator times 1 down here. Let's move forward. Let's clean things up a little bit more. So I don't, that 1 just essentially gets absorbed, goes away. And this exponent of 1 up here is unnecessary. We don't need it there. It's not really doing anything. Now let's distribute. So we get negative 3x to the 4th plus 25x squared minus 9x to the 4th. We're almost done. So now we're just going to combine whatever we can, combine like terms, and that should do it. So negative 3x to the 4th minus 9x to the 4th, well, that's just going to be minus 12x to the 4th plus 25x squared over 25 minus 9x squared to the 1/2. This is good right here. This will get you full credit. If I wanted to, I could technically factor out an x squared term, but you don't have to. Now, with a problem like this, I might ask you to find where the function has horizontal tangents. And of course, what that means is setting this, the derivative, equal to 0, or essentially solving for the zeros of the derivative. And because this is a rational expression, solving for the zeros of a rational expression basically means set the numerator equal to 0, find all the roots, and then just plug the roots into the denominator and make sure none of those give you 0. So that's pretty much it.